Hello everybody, it is Caleb, and today I want to share with you how to use and the files for the completion of my asset creating scripts. What I'm talking about is in these moving lights inside Unreal Engine, it requires a lot of assets to be made, and frankly it can be kind of a pain to create all of these, especially by hand. Now, before I get into this video, I do want to give a very huge and sincere thank you to all of my Patreon supporters. And if you're getting value out of these assets I've created, I kind of want y'all to give a thank you to everybody here as well. Because I did promise to make these scripts and executables free for y'all to use. Nobody here had a problem with that. Everybody liked that idea. So Eterno, thank you for being a member since almost day one. Secret Meeting, thank you for staying subscribed. Stephen Thompson, thank you. I did look into that, Stephen, by the way. Unreal Engine 5.5. It looks like it's because of mega lights needs to be disabled, but it just looks like 5.5 is bugged. Thank you, Maxime Rouleau Villeneuve. Got a lot of value out of your content. Aaron Sanchez, thank you. Endeavor, thank you. And thank you for the suggestion on the Valero wave. Matt Ford, thank you. Tom Hill, thank you. At CTK, thank you for subscribing. Leo Paul Asola, I still want to talk to you, but thank you. And then some recent subscribers, Jesse Magana. Hope that 5.5 or 5.4 is working out for you. MK Ultra, I had an awesome time talking to you today. iMad Kais, thank you. Thank you everybody here for subscribing to my Patreon and supporting me during this time that I am making these assets for everybody here to use. Your guys' support is really what pushed this community forward and made this, I don't want to toot my horn and call it a breakthrough, because I'm just responding to what needs to be done and responding to where Unreal Engine left off on development before disbanding the DMX plugin. So thank you everybody. If you guys want to see the fixture that Endeavor requested, this is it. I think it's pretty freaking awesome. My only issue is the lights up there look like pin spots, or look correct, but down here the actual light looks like a little laser. So I need to find a way to make the start radius of the spotlight bigger. But thank you to all my Patreon supporters. I'm sure everybody else thanks you for helping me out, giving me some summer money. I live in Arizona, by the way, and so in Phoenix, and summers here get extremely slow. So this Patreon supporting really helps with some summer money, and just helps me stay stable and able to pursue this instead of getting like a warehouse job or just pursuing freelance work that I might not want to do. Thank you everybody. Let's get into the meat and potatoes of this video. So what I have done is made some scripts and made some executables that make all of the assets that are needed to create your own moving light fixture using the Unreal Engine DMX backend. What these assets that are created are, and I'll use the Maverick MK3 spot as an example. First off, I have created some engine content that enables use of double gobo wheels and triple gobo wheels. And so here's one that's an example. You've got a fixture that is the mega point. And if I go over to my lighting console and I select the mega point, I can go to an open gobo. I'll solo this to make it easier. I can go to an open gobo, or I can partially obscure the gobo with another gobo. So this is an example of a double gobo wheel component. And then in a unit like the MK3 spot, I can overlay gobos up to 3 gobo wheels. So now I'm going to change gobo wheel 1 to something that shows a little bit more. and then I can go to gobo wheel 3 and overlay something else. And so all of these multiply together. This is all in my latest fixture pack. But the assets that I'm going to provide to you, I'm going to provide to everybody, free of charge. And these are the assets that they create. So if I go to one of my folders, like the Ayrton Diablo, which only has one gobo wheel, the assets that it makes are CSV files that create the gobo table, the color wheel table, the strobe table, and the spin table, whether it's 8-bit or 16-bit. And all of these are CSV files that look kind of like this. This would be the spin table, this would be the color wheel table, and all of these point to engine assets, wherever this is, up here. The gobo table, however, points to assets that are already in, or the open gobo is already in the engine content, and then the other gobos that it points to are in a special folder within that fixture, so specific to that fixture. You can share some of these assets with other fixtures, but for now I'm just importing them individually. So let me show you how to make these. The other assets that it makes aside from the CSV files are texture disks. So this is what the gobo disk would look like. And this is what the color wheel disk would look like. So let me make one for you now and show you kind of the outline of these fixtures. I'm going to use my special trade show booth here, and I'm going to name one of these the Force to Profile. So let's get started. I'm going to minimize this and then take you into the executables. I have them in a folder somewhere. These are completely compiled executables. That's empty, apparently. Give me 1 second to recall these. And then we're going to build a CSV Force to Profile. That one should work. First thing we need to do is go to the GDTF website, find our fixture. Of course, you got to log in. And then we're going to go to CSV. Maverick Force 2 Profile, and download it. Second thing we need to do is unzip it. And so I like to put these in a GDTF library. I'm pretty sure the Force 2 Profile is already in there. It is. So just pretend that I copied that from my downloads folder into here. I'm going to delete this. We need to go to 7-zip file manager, go to this GDTF file and unzip it. So that's the Force 2 Profile. We're just going to hit extract, and it's going to drop the folder in the same folder that I got it from. We're going to use both of these to create our Unreal Engine fixture actually. And we can close PyCharm. So now we're going to go to wherever that thing was. And we're going to start with the most complicated one, and that is the gobo wheel. Let's go ahead and run this. And it's going to bring up a terminal page that you are going to use, and it's also going to open up a browser window. We're going to go to our GDTF file, the one that we unzipped, and we're going to find the description file. We're also going to need to make sure that it has a wheels folder in it, and that wheels folder contains the gobos. So if we go to this wheels folder, you can see that it has a texture for all the gobos. It has to be in a folder called wheels. That's where the script is going to look for it. If you don't see this wheels folder but it's in another name, just go ahead and hit F2 and rename this wheels. But the file that we're going to look up is an XML file. So let's hit open, and then it's going to ask you what mode you want to build for, or specifically what mode it's going to parse the values for. Now on something like the gobo wheel and the color wheel, it's the same wheel between the two. Like, the wheel can't physically change, but what might change is whether it's 8-bit or 16-bit. I honestly haven't prepared the gobo wheel for a 16-bit gobo wheel. I hope I don't encounter something like that, because frankly I don't see the point in a 16-bit color wheel, but it exists sometimes. So we're going to type 1 for the 50 channel mode. Then it's going to open up this GUI, and if we expand it, we can see that we get the rest of our gobos. All you have to do is click on, this is the attribute name, and then these are the channel sets. And so all you have to do is click on which gobo wheel you want to build for. You don't have to build for both of them, but it's kind of recommended if you want to use both of your gobo wheels. So we click on a gobo wheel, click on our first channel set row, and if it's an open gobo here, we just click on this assign open gobo, and that will link it to the engine content gobo, and it will also use a predefined open gobo when it's creating the texture disk, because every open gobo is the same. From there, we click on our next one, our next channel set, and all we're doing is matching this gobo name to here. And you'd think a script would be able to do this, but given that every texture name sometimes doesn't correspond with the gobo name that's in this GDTF file, this is why I had to make this GUI. All you have to do is click on the button. It'll turn gray once it's used. You can click on it again, and then it'll auto advance to the next one. So radial dot, dots, bolts, and then in this case it actually goes in reverse. In most that I've found, it will repeat from the beginning. So this next entry would be sailboats. If it does do that and you want to copy, you can hold select or hold shift and then select all of these, and then either right click and hit copy patches, or just hit Control C and then Control V. But given that it mirrors, we need to do this differently. So 4 eyes, patch to 4 eyes, ballistic clouds, shower glass, bolts, dots, radial dot, and another open one. And then once you get to the gobo scrolling, that's when you do rotation clockwise or rotation counterclockwise. Then the other thing you want to do is normalize your rotations. Because Unreal Engine will read this rotation clockwise as a function to do, if it's rotation clockwise but it's given a negative value, it's going to rotate counterclockwise. Because of this, once it gets to the counterclockwise action, it's going to want to rotate this way, and because it's given a positive value, it's still going to rotate this way. So what you're going to get is both rotations go the same direction in Unreal Engine. And so to fix this, I provided a normalized rotation button that makes them both positive. And then this part's kind of clunky, I'll improve it later, but you want to scale down your rotation effect value to be a max of about 20. I'm going to do my next gobo wheel now. And here's one area where I can copy and paste. So I go sailboats all the way down to 4 eyes, copy, and I did that slightly wrong. Paste, and then this one's open gobo. Then from there I just keep patching. The other thing you want to make a note of, and you might want to just take a picture of this, since currently you can't copy the text here, that's probably an improvement I'll make in the future. But you want to make a note of what this default texture asset, this is what it's going to write to the CSV file. You want this exact manufacturer name in your Unreal Engine folder, in your fixtures directory. So I have mine saved as GDTF Professional, not just GDTF. I'm going to delete this. And then your fixture name, Maverick Force 2 Profile, you want to make sure that corresponds to a folder that's in here. Once we're done, we're going to hit export. And it's going to save all of those CSVs and disk images back into the root folder that you pulled it from. So now if I go to GDTF Force 2 Profile, you'll see it has a new folder CSVs and a new folder named disks. And these disks aren't very large here, but you can see it's got all the gobos lined up in a row, and then the frosted version is just it blurred, and it's actually multiplied to make it brighter. Otherwise the blurred version would be considerably darker. And then the CSV files, if you open up in Excel, would look something like this. For some reason, it has to save the name. Oh, so one thing the script does is convert these spaces into underscores, as Unreal Engine would as well. The other thing it does is on these disks, if you have a manufacturer that's provided a gobo that is where the blacks are not truly black, where they're a little bit gray, maybe it's like a red, green, blue value of 10, I think its threshold is 15 or 20, and it will reduce those back to a true black. And the Unreal Engine asset actually does not do this. So we're going to repeat this process for all the modes. And if you have done the higher channel mode first, and you can see that the DMX max does not go up to currently I have to modify it where if it's 16-bit, it will actually go up to 65,536. But if you see these values progressively going up to only a value of 255, you probably don't need to run this script again for the 33 channel mode or for the lower channel mode. If it's going to be 16-bit, the manufacturer is probably going to put that 16-bit in the higher channel mode. But if you do run one of these and you run the higher channel mode and it's 16-bit, you probably need to run this script again to make separate assets for the 8-bit mode. And currently the color wheel will identify what is in the name, in the file name and outputs. it will identify if it just made an 8-bit or 16-bit, or it'll actually identify the channel mode that you used. If you do have to change this and you run the script again on the lower channel mode, what you're going to notice is this will overwrite the files. And so what you might want to do then is just rename it and call it like 16-bit or call it 50 channel, so that when it outputs the new files, it doesn't overwrite your higher channel modes. So that's one thing to consider. I've put a lot of work into these scripts, but I still have a ways to go. I just want to get them into y'all's hands because quite a few people now have asked me about how to make moving light fixtures easier. Some people are punching in these values into Excel and CSV files by themselves, and then photo editing to make the disk textures, and that just sounds awful. Frankly, I've done it and I barely got through one fixture. Once we're done and you hit export, I've made it so that the window doesn't close. It stays open if you need to make any changes, but once you're all done, you can hit close. I'm pretty confident, so I'm going to close it and then run our next script. Let's run the color wheel. And then once again, I'm going to run 50 channel mode. I've yet to get to the bottom of this error. I think it's done by requesting the manufacturer and fixture name. So I had to implement this top change here because of the high-end fixture, because sometimes the attribute that actually has the color wheel and its stop positions is not called color 1. It's sometimes called something else. Once again, we're just going to select our first row and match the name with the corresponding color. And this will go to engine content, not imported content. So we're going to go white, red, orange, green, magenta. I don't have a way to make a custom color yet. I did at one point. I'm just going to use blue here, and then I think CRI is CTO, and then CTB. And then on a fixture like the Roby, for some reason, these DMX froms and DMX 2s were offset by a bit. If they are and they're not showing correctly, or you're trying to go in your console to solid colors and you're getting half colors, or you're getting part of the other color, you're going to need to apply a DMX offset to try to get that value to where it needs to be. Once we're done here, we're going to export this, then move on to our other ones. Spin table relates to the gobo position rotate, not the gobo scroll. So once again, GDTF library. And then because the attribute name changes pretty frequently on this one, I need to change this number up here to say 20. 10 is a little too slow. But because these numbers change, these names change so frequently, we're going to, you have to select the attribute and find what you're actually looking for. What you're actually looking for is something along the lines of gobo position rotate. And you only need to do one position rotate, even if it has 2 rotating gobo wheels. The reason for this is because currently Unreal, if you go back to my project, if you look, it's spinning the entire light. It's spinning the lens, and it's spinning the beam mesh. And so it only takes one gobo spin channel anyway to rotate all of the gobos. Because of this, it also inaccurately depicts one rotating gobo wheel spinning against a static gobo to kind of act as a mask for that. The bonus here, though, is that if you're working on a virtual production and you want spinning gobos, every gobo wheel is a rotating gobo, as long as you spin one of those channels. So we're going to look for something like this and then do a very similar thing. Now this is a 16-bit version, and like I said, these scripts have some issues. One of them is that it doesn't detect if I'm using a 16-bit or not. And so it'll always put, in the GDTF file, it only provides the range min. And so what I told the script to do is just slap a 255 value at the end of this. And I wasn't anticipating for 16-bit values. But that's very easy to fix in Unreal Engine. So I'm going to add spin clockwise. Now where it says stop, Unreal Engine has a bug here where if it's given a stop function, it will dump the gobo and go to an open gobo. Why does it do that? I don't exactly know. So what I like to do instead is either give it a spin clockwise or spin counterclockwise here where it says stop. Because spin counterclockwise or clockwise with an effect of 0 will result in a stopped spin. So let's go ahead and just give it spin clockwise, and then these three are spin counterclockwise. And then again here we want to normalize our effects because a negative value will result in it spinning the opposite direction of the function it says. So a negative counterclockwise value will result in it spinning clockwise, which is the same direction as this positive value clockwise. And then 360 is ridiculously fast in Unreal Engine, so we want to scale this down so that the values are about 20. Once we do that, we can export. And that's all we need to do since we're only doing one spin table. The other script to run is shutter, and quite honestly I feel like this is the most useless because a lot of the times in the GDTF file it doesn't have the proper names for things written anyway. So we go to GDTF library, and here you'll see that some of these values that it says just don't make sense. Normally there is the channel set name will have like strobe, pulse, random, or burst. I've never seen sine wave yet, but it's a function in Unreal, so I put the button here. But two important ones are closed and open. So this one's closed, this one's open, and I'm just going to guess that these are strobe. Now one way to verify this is to open another visualizer, like maybe MA3D or Capture, one that maybe got it right, and then view with a lighting console, inject the values and see what it comes up as or what it looks like in your visualizer, and then try to match that to a function here. But for now I'm just going to kind of give it random values. The other thing is your effect here, this should be increasing. Maybe I can make a way to increase it here in the editor, but you could also do that in the data table in Unreal Engine. And like here, why isn't there a name here? This is pulling data, this isn't me, this is pulling data directly from the GDTF file. So I'm just going to be safe and say that these are both open. No need to scale down my effects. And then I export that. And now I have created all of the assets that I need to build a fixture. So now we're going to do that. One thing I like to do is to copy one fixtures folder to another location instead of having to bring in all these effect tables, because all these effect tables have a different structure. Unfortunately, I don't really know how to duplicate within a folder, so the workaround I use for that is I just drag and drop to a different folder than it's currently located in, copy, find where I put that, and rename it to my fixture. Now notice I have to name it exactly as the GDTF file would expect, and so or what my CSV file would expect. So if I go into my Excel spreadsheet, or if I just rerun the gobo script, and then just click on any one of these, I can see exactly what name it's going to put in the CSV file there. So it's called Maverick Force to Profile. So let's rename it that. And then we can drop this back into our Chave Professional folder. And now we have our folder to start building from. I'm sorry, Freedom Park Quad. I promise I'll get to you someday. So we're going to go into these effect tables. I don't know why I have a Mac Viper Air Effects color wheel here. I think that was just a mistake. And we're going to, under this top row, under data table details, find our source file. This is in our GDTF library, and we're looking for the CSV files we just made. Force to profile, we are looking for gobo 1 data. This is for a color wheel actually, and you can see that up here. So for this one, it's actually going to be color wheel. And then we can hit re-import, and note that these assets that it's linking to have to be present when you hit re-import. We can save and then rename this And then what I would do is copy this name to your clipboard so you can easier pop it in. We're not using the Force 2 only has 2 gobo wheels, so we can delete one of these. And then for our gobo wheel 1, what we have to do before importing that is go to our gobo wheels. Notice that these images look the same, but they go by a different file name. And so to do this, we're just going to, we can import all of our disks at once. But you do have to do something specific with the color wheel, and I would do this right upon importing it so you don't forget. Otherwise, if you do forget, it could crash your engine. You have to go in here and double click it, and then change the compression settings right here from default to vector displacement map. If you don't do that, it'll crash your engine. Once we do that, now we can go back to our effect tables, go to our MK3 gobo, or what's going to be Force to Profile, gobo 1 table, and get our new source file. CSV, or we're in Force 2 profile CSVs, gobo 1 data, re-import. I was hoping that wouldn't happen. So somehow it's failing to link these texture assets even though I've provided them here. So let's try figuring out exactly why, and hopefully this doesn't happen with other scripts. Let's go to gobo 1 data. Maybe I made a typo because I swore I just fixed this. So oh, I know what I did. These disks are supposed to be in here. That was my mistake. Some of you are probably saying, what on earth is Caleb doing? I'm going to unsubscribe right now. So we can just drop these into our disks. Gobo wheel is supposed to be a copy of this wheels folder. Now that we've imported these, let's try this again. Effect tables, gobo wheel table 1, re-import. There we go. Now the folder name, and asset name match exactly. And note that I had to have the script turn spaces into underscores. Just know that if you're going to dig into the open source. You can save this, and then we'll rename it Force 2 profile, gobo wheel 1. Go to our gobo wheel 2. Do the same thing. And once again, it links to all of it. Spiral goes to that's not correct. Oh, okay, it just took a second to bring up. One thing you might notice is that colors don't come through on color textures. I've yet to figure that one out too. And what's funny is on a previous version of making this, the colors did come through. I don't know what happened to that. And then do the same to our spin table. Then, like I said, this doesn't go up to 65,536. So here, we just have to manually change this value to be the maximum 16-bit value, which is 65,536. Told you it was easy. Go ahead and save, and then we do have to run our script one more time, depending on how they built our GDTF file and how they made this profile in the fixture. So we're going to go version 2. Now you can see that this spin table goes up to 255. So we do have to build this one again. But it's going to change the name so it doesn't override each other. Okay, and then we export. We can close that, and then we can find this asset in here, 33 channel spin table. Open, re-import, and we're done. Go ahead and save, and then let's rename this to Force 2. I feel like we're missing one thing. And the thing we are missing is the shutter table. So let's copy that in from somewhere else. You could bring it in from your copied engine content. And then we're going to find our source file. And there we go. And then because all of these effect values, which I think in the GDTF file is called physical 2, because they're all 1, if you do want your strobes to get faster depending on where you're at, you might need to up these. So like, you might need to say that fast is 10, is between like 8 and 10. This one's between 6 and 8. This one's between 4 and 6. This one's between 2 and 4. And then this one is between 0 and 2. And that should make this strobe function in the engine get faster, because it's going to read this value to determine its speed. So let's save this, and then we can go about plugging all of these assets into our fixture. First thing we need to do is delete our old GDTF file, and then we're going to go back into our downloads. And now we're going to import the unzipped GDTF file into the engine just by dragging and dropping. For some reason, my window always appears here. We don't need to import textures or models. We've already got that handled. Maybe someday I will be able to import the models here. But for now, quite honestly, I'm just using the stock model. I will eventually update these fixtures with models, but I wanted to get them working in the way that they are supposed to before I get them looking the way they're supposed to. So let's hit import. Next step is to build this in our library. And so I'm going to add a new fixture type. Its category is moving head, and by the way, this only determines where it falls in here. This name does not need to be exact as long as you can recognize it. We don't need to add modes or anything. We're just going to go back to our fixture. And then our GDTF that we imported, we're going to drag and drop it in here. And it will auto-populate all of our channels. Now, one thing to look for as you go through this, and I would do this right when you import it before you get into the heat of things, otherwise you'll forget. Or at least I'll forget. I don't know about y'all. But pan, correct. Tilt, correct. Dimmer, correct. Shutter and frost and color and gobo are notorious for some reason putting a 1 after their name. And the component in the moving light won't be looking for the name shutter 1. It'll be looking for the name shutter. Same goes for color, which is color wheel. You want that to just say color. Gobo 1 I reserve for gobo 2 because gobo 1, the actual channel, gets gobo. Think of that as gobo 0, and then gobo 2 is gobo 1, index 2. Gobo 1 position corresponds to gobo spin. At least that's how I do it. And then gobo 2 position, because you're using the same spin table for both, could just be no value. Frost 1, we need to correct this to frost. And then everything we just did, we need to do it again for 33 channel mode. And this gets real tiring if there's a whole bunch of modes, but consider this a lot easier than building these modes yourself. You could actually probably double these up. I'm going to try it. Double these up so that both of these relate to gobo spin. And then if you change either one of these, the hard part will be like if you have a value in both of these. Let's see what happens though. If we have to change it back, we can. Okay. Once we've done that, we can save our master library, and then it's probably good to do a save all to save all these assets that are loaded in. We're now going to go to our blueprint class, rename it to what we want. And then we can start editing it. Now, if you have my pack and you have the gobo 2 or the double gobo wheel component, you're probably going to find, well, you might just find a regular gobo component in here. Whatever you currently have, you have to delete that component, and then this update component won't have a target. If you compile it, it'll give an error. So then you have to add in the component that you need. This is a double gobo wheel component. Drag that object in. This won't go to here. So you need to then say update component, because we're calling a function in this component. We can't fit the same function to all components. So connect your event pin, connect your delta seconds, delete, move it into a pretty place. The other thing you'll need to do is make a CMY color component. And by the way, I will make a video explaining how this double gobo wheel component goes together. It was a lot of functions though, and quite honestly, I moved straight from making that double and triple wheel gobo component to building another multi-instance fixture, and forgot to document the entire path. So that's going to have to wait for another video, but quite honestly, that's probably another 30-minute video in itself. The CMY color component is something that you have to add. And I don't think that doesn't have to be linked to your update tick. Let me just show you what the CMY color component is though. All you're going to do is find your color component in your engine content, duplicate it, and normally it'll look like, I think it's just, well, let's find it real quick. So the color component looks like this. Just new color goes directly to set light color and set vector parameter value. The CMY component, on the other hand, all I do is break this and then flip it to the opposite. So if this is 0.1, I need to make it 0.9. If it's 0.2, I need to make it 0.8. If it's 0.5, it needs to stay at 0.5. And so how I do that is just by multiplying the number by -1 and then adding 1 to it. Then I remake the linear color, and bam, I have now converted an RGB value to a CMY. Not converted RGB, but the data values that come in from your console and how it expects a CMY flag to work. This will give it your expected value result. So if you have a color component in here already, which I'm pretty sure the stock Unreal Engine fixtures do, you need to delete that and then add in a CMY color component. And I don't think, let me just do this real quick. Yeah, if you delete that, there's no real dependencies on it. It's just the presence of it makes it update the color. Now I'm scared. Which one do I want? Yeah, I want the one that's in my engine content. All right, once we do that, we're basically done. Just ensure that if your fixture has a frost component, you add that. And ensure that if you have a strobe component, you have that in there. And if you have a color wheel, make sure you have a color wheel component. For some reason, the color wheel component, it looks for the name velocity. I don't know why. So we have to change this to look for the word color. And that said, you can have this respond to any arbitrary name. If you, on your DMX profile over here, if you're building something weird, library. If you're building something weird and you want your color wheel component to respond to be listed under here under the name magenta for some reason, as long as you make your color wheel component look for the name magenta, it'll respond to it. I'm trying to keep things conventional though, so in my library this goes to color. In my color wheel component, it picks up on color. And then under effect table here, this is when we bring in our tables. So color wheel table goes here. Before I drop this color wheel disk in, I'm just going to make sure everything's saved due to it's prone to crash. Drop it in, we should be good. And then do the same to our gobo wheels and all of our other things. So strobe component wants a strobe table, so we'll give that strobe table. Our double gobo wheel component is what takes in our spin table, our gobo tables, and our frost textures, or in our gobo textures. So let's start by adding the disks in. This is gobo 1 clean, gobo 1 frosted, gobo 2 clean, and gobo 2 frosted. And then, and again, if you're working with just the standard engine content, this is only going to have one table, one clean disk, and one frosted disk. We need to add our effect tables here. Gobo wheel table 1 and gobo wheel table 2. And then in our spin table, feed that our Maverick spin table. We can compile and save, and then we just need to, well, we've done everything now. So now, if I exit, and then we drop this asset in, theoretically it should be working according to our lighting console. So let me patch this in on the lighting console. I'm over on my parameters, so I might have to disable a universe. I'm going to operate it in 50 channel mode. And then its universe is going to be 7001. If you're working on something and it gets problematic, it is nice to be able to patch this at the start of its universe so that you can go to your DMX activity monitor and track down exactly what you need. So you'll be able to see what fixtures are doing what, or what channels are doing what. I'm going to save this. It's fixture 23. And notice how nothing came up. So I have to disable, because I only have a 1024 parameter node hooked up. So once I disable that, my universe 1 stops being active, and then 7 becomes active. Now that I've done that, and I have my DMX input for that fixture, I can go to DMX, Patch Tool, Master Library. Oh, I need to add it in my patch in Unreal first. So let's go back to here, DMX, fixture patch, and let's add in a Force 2 profile, 50 channel mode at 7.1. Save that, and now we can patch it through here. I like to patch it through here because it will grant, patching it through here will grant that asset DMX while it's in editor. If not, you have to hit play here and put it in runtime. So to have it in editor is really nice. Okay, it's a good sign if it's sticking upright. So I'm going to go back to my lighting console and let's test this. So let's say at full, that works. Moment of truth on our gobos. That seems to be working correctly. Bolts. Let's go to sailboats and then go to gobo wheel 2. Alright, it's not working there. Oh. Why did it... It's not showing the right gobo. So if I open this up, This is supposed to be brick wall. One thing I can notice, I think the GDTF file was incorrect, because in Grandma 2, which I'm assuming Grandma 2 is right, I would actually prefer to use Grandma 2 for this specific instance if I'm trying to figure out exactly what the real fixture looks like without having the real fixture in front of me, because Grandma 2 has been around for longer and has been tested with these fixtures more. If it's a fixture that came out after Grandma 3's release, by quite a bit, I'd probably want to use Grandma 3 to prove these values. So what it looks like in here is not what matched the GDTF. The GDTF said that I used gobo wheel 1 textures in addition to gobo 2. So I'm actually going to leave this up and then rerun my script again to make this correct. I was wondering how exactly Chauvet built and why they would build a gobo wheel 2 that has the same gobos from gobo wheel 1. So let's do gobo wheel. Alright, description, we're going to run 50 channel mode. And then we're not even going to fill out anything for gobo wheel 1. If we don't fill out anything, it won't export those assets and it won't override our assets. So what we need to do, it looks like, is I don't know exactly. This might be problematic. Let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I think we're lucky in that what it claimed was gobo wheel, like copies of gobo wheel 1, is the same quantity as the gobo wheel 2. But if you could see in Grandma 2, it's 1, 2, 3, 4, 5, 6, 7. Then it goes to indigo, and then it goes back to indigo. So we're going to do these instead. Open, and then I'm going to reference Grandma 2 here. So first it's spiral, then abstracts, brick wall, chess, Granny Sue, color weave, indigo breakup. Now we can go to what it actually says. Indigo, color weave, Granny Sue, chess, brick wall, abstracts, spiral, and open. And then slow to fast, normalize, scale down, and we should be done. So let's export these. And then if we look in our terminal, oh, we've got a lot of stuff running still. Yeah, it only wrote CSVs for gobo 2s. It skipped gobo 1 completely. So that's good. Now we can just modify. We should be able to just drop these assets in. I'm going to save first. Should be able to just drop these assets in. So gobo wheel 2. Luckily it's still saved to the same thing, so we should just be able to re-import this. There we go. Spiral, abstracts, indigo, indigo. Save this. Our disk we need to update because this is what it claims and that's not correct. So let's drop those assets in. This is why development for these scripts has been slow. Because GDTFs are super inconsistent. Okay. Now that I've dropped those in, it did auto update this. If it doesn't auto update, which I've had it do sometimes, you might have to go to your gobo component and then re-drop these in. Or re-drop the effect table in. But it looks like it auto updated. So let's try this out now. If I go to spiral, it'll go to spiral. There we go. Abstracts, abstracts. If I want to, here's what I'm curious. If I go to spiral, then I want to overlay that with a gobo wheel 1. Cool, it'll do that. Now, like I said, inaccurately, it will spin the entire gobo wheel instead of spinning just one gobo layer. To do that, I would have to spin the entire texture, which means spinning the entire disk, because it reads the disk, oddly. It does not read these textures. It reads the disk texture and then offsets where it is. So I would have to spin this entire disk. What I'm curious of, though, is because we, on our DMX fixture, because we made 2 gobo spins, or I thought we did. Let's try it. 2 gobo spins. Wonder what happens if I bring this to 50. Oh, it's not spinning anymore. And if I go to gobo wheel 2 and try spinning it, it's, oh, there it spins. So it seems to take the later one. I'm just going to bring this back to select a value, leave it blank. Oh dear, I may have done something. Well, it's going to read from gobo wheel 1. So if I say stop, yeah, it's going to overwrite that value in the blueprint. Now I bring it back to spin, it will. I don't have any encoder wheels set up, but what it should do is, as I get real close to 57.5, let's say 56, yeah, it'll spin really slow. Then if I bring it to stop, now if I bring it to 59, it should spin the other way. There we go. Okay, let's test out the color wheel. I'm going to open up one of these gobo wheels. Let's test out the color wheel. I go to red. Cool. Orange, green, everything looks correct. Not even MA knows what CRI means. CTB, is CTB different from open? Just by a little bit. And then probably the most inconsistent thing is shutter. So let's see what max strobe does. Okay, max strobe does something. Min strobe should be doing a minimal strobe. What happens if I bring this to 6? Okay. And so here we can see min pulse and max pulse. Max random. I think that's because I think it's not doing random. Frankly, the random doesn't look like much anyway. But I think it's not doing that because in our strobe table, the last one we have is, oh, it is random. Oh, I got it correct. Either that or MA guessed just like I did because the names weren't in the GDTF. And so there it is. That is building a fixture Not from scratch, but piggybacking off of Unreal's system. So I hope you all enjoyed this. And hope to see you all around sometime.